Hey, this is Mr. James. In this video, we'll be doing a tutorial about rotations. In this video, we're going to skip over the introductory stuff and go straight to constructing and drawing different things. And so we start here. Find the direction and the angle of rotation for two figures below. Notate the rotations using letters and symbols. There's only one method to do this, and that is to measure the angle using a protractor. So start by picking one point on the image and one point on the pre-image that correspond to each other, such as A and A prime, and draw the angle from the pre-image to the vertex to the image. Now I picked A and A prime, but you can pick B and B prime or C and C prime, that's fine. Okay. Then take your protractor, line up the center of your protractor right at the vertex, just like that. Line up the baseline of your protractor with one of the rays, one of the sides of the angle, just like that. And then read up, starting at 0, to find the measure of this angle. And I'm reading about 75 degrees. So I would say that this is a 75-degree rotation. But also what's the direction? And so are we going clockwise or counterclockwise? Well, to tell that, look and find which one is your pre-image. I know this is my pre-image because it doesn't have that little apostrophe to show that it's the image, but the prime. Over here, A prime, that's my image. So it must be moving in this direction, okay? Which is rotation, let's think. It's the way a clock goes, so it's a 75-degree rotation, and it's going to be clockwise. Okay? If you want to use the standard notation we learned, it would be a capital R for rotation. Then I write the center, D. Then I write the degrees of rotation, the angle, which is 75. And remember, clockwise is actually negative. Okay, so it's going to be rotation around about D of negative 75 degrees. And then what am I rotating? I'm rotating A, B, C, and D. So A, B, C, D. And that is how to notate this image right here. Go ahead, pause the video, and try to find the angle of rotation from this pre-image to this image around the center of rotation E. Pause the video now. The answers will be up in 3, 2, 1. Here is our result. I've measured the angles right here, and I've gone from A prime to the center of rotation to A, right? That angle right there. I've measured it with my protractor and gotten about 52 degrees. And notice that's counterclockwise. I know that's because my pre-image is here and I'm moving towards my image in this direction. It's counterclockwise. And so notated, that's a capital R for rotation around point E of 52 degrees. Again, it's positive because I'm going counterclockwise. And I've rotated the points A, B, C, and D. Next, they ask us to construct the rotation, that's capital R, around point Q of negative 60 degrees, which means that's 60 degrees going clockwise, of ABC, so this triangle right down here. Now there's two methods of doing it. The regular way we'll do uses patty paper, this transparent paper right here, and a protractor. The honors method for a 10 out of 10 or mastery is going to involve a compass and a protractor. So we'll start with the regular method first. What you'll do is, before we even use our patty paper, grab your compass and let's draw a 60-degree angle. So first, I'm going to draw, pick any of these points. I'll pick point A and just draw the angle from the center, or ray from the center of rotation through that point. There's that. Next, I need to make sure I draw a 60-degree angle going clockwise. That's going to be this way. So I'll take my protractor, put the center here, line up the edge, and then go up until I see 60 degrees, make a little mark there, okay, and then draw that angle. This will help me be able to rotate my triangle, okay? So now I've got a 60-degree angle here. Perfect. What I can do now is take my tracing paper, my patty paper, and trace my figure. Okay. I've got C, I've got A, I've got B. And I'm going to mark point Q, and I'm going to mark one of these rays right here, of that angle. Next, I will take my pencil and hold it down and rotate my figure, in this case the triangle, that 60 degrees until it lines up with the second ray. This is a 60-degree rotation about point Q. Now what you need to do is very carefully punch through your patty paper, just so you can put those points down. Okay. You can use a pencil or a pen for this. Okay, or any other sharp implement. Okay. And now when I take my tracing paper away, I can see where my new points have to be, my image. And I'll use green for this. Okay. Just connect those points. And this is going to be A prime, B prime, and C prime. And that's it. That's all you need to do. At this point, pause the video here and try and perform this rotation. A rotation around point S of 150 degrees. It's positive, so that means it's going to be counterclockwise in this direction of RST, so this triangle right here. So you're rotating around that point S, 150 degrees. Go ahead and pause the video. The answers will be up in 3, 2, 1, and here's my result. Again, I took my protractor, I measured out a 150-degree angle. You can see right here, 150 degrees. Then I took my patty paper, I traced my pre-image, including one ray of that 150-degree angle, and I rotated until I hit that 150 degrees, just like that. And then I broke through that and connected the points to create my image, S prime, T prime, R prime. We're going to go ahead and save the honors method of doing this for the end of the video. And we're also going to skip the next section, which uses an honors method, and go straight to this section right here with coordinates. Sometimes using a coordinate grid is useful when performing transformations such as a rotation. So let's take a look at the first one. First one says we're going to perform a rotation around 0, 0. That's the origin right here, so let's mark that. Okay. 90 degrees, and it's positive, so it's going to be counterclockwise. Let me just mark that direction, 90 degrees, of YAW. So to do this, I like to take out my patty paper, my transfer paper again, and outline YAW. Okay. YAW, and I'm going to have to do this 90 degrees. And the easiest way to go about this is to mark the axes, okay, on your paper, and put your pen right in the middle, and go ahead and turn it 90 degrees. So it's going to be 1/4 turn. So if I turn this 90 degrees, what will that look like? Oh, went a little too far. There it is. Okay, and everything should line up on coordinates. And so I can just poke through my paper, just like I did before. Okay. Okay. And so it seems that W prime is up here, A prime is here, and Y stays where it is. Because it was the center of rotation after all, I can go ahead and connect my points like this. Okay. And if you do these a lot, you can start to get the hang of them and do it without the transfer paper. There it is. Pause the video now and try and perform these next two rotations without me showing you. The answers will be up on the screen in 3, 2, 1. And here's my result. For the first one, my pre-image gets rotated 180 degrees about the origin. Here's what I did with my patty paper. I traced it just like that. I held my pen right in the middle, and I rotated it. It's 90 degrees, and that's 180 degrees, and that is where my image fell, just like that. For the next one, it's a little trickier. Watch out because it's not around the origin anymore. My center is now -2, -2. And so if you remember how to find your coordinates, -2 on the x-axis, -2 on the y-axis, and so I'm actually going to be rotating around point J. And so what I did is I took my patty paper, instead of making my little axes around the origin like I did before, I traced the triangle, but then put the center at J. So I'll put my pen here instead of here, right here, and I'm going to spin -90 degrees. That means that's 90 degrees clockwise. So that's in this direction right here. So Go ahead and spin that. And boom, there it is. Everything lines right back up. A quarter turn, and I just record my points right on the grid. Normally we would stop here, but I'm going to go ahead and do the honors methods of constructing a rotation and finally a center of rotation. So if you do not wish to see the honors methods, you may stop the video now. Otherwise, here we go. Instead of using patty paper, we're going to use our protractor and a compass to do this. So we must start by drawing a 60-degree angle for one of our points, and we're actually going to have to rotate every single point separately. So I'll start there, and now let's draw a 60-degree angle from B. Okay, I'll just draw that quickly. And so B is rotating 60 degrees in this direction. However, where on this line does it fall? Well, to figure that out, we're going to use our compass, because we know that rotations preserve distance from the origin. They're spinning around there in a kind of circle. So I take my compass, okay, and just like that. And so B prime is going to land here. Again, 60-degree rotation, and these segments are the same right there. Now we should continue to do that for all of the other points. So I will do C next in green. So there is C. Let's do a 60-degree rotation of C. 60 degrees. Okay. I've got my angle, but now I need to know how far up. So I take out my compass again. Okay. There it is. C prime lands there. And now I'll rotate A. Okay, let me draw this ray right here. Okay, and then the 60-degree rotation will land me somewhere on this ray. Okay, they're all being rotated 60 degrees. But then how far on that ray? Well, we've got to use this compass again from Q to A, rotate it around there. Okay, there it is. A prime lands here, and now I can go ahead, now that I've rotated every single point by 60 degrees and kept the distance from the point of rotation. I can go and connect my points right here and obtain my image. A little more complicated, a little more technical than the previous example, but if I pull out the old patty paper from before, you actually notice it does the job quite nicely. Look at that. Boom. And no patty paper. That's the honors method. To find the center of rotation using the honors method, we'll have to think back to how rotations are created. Remember that rotations are the composition of two reflections, and we can find the line of reflection by drawing the perpendicular bisector between the image and the pre-image. That's what we'll do here. So pick a point on the image and a point on the pre-image. I'm going to choose these right here, and draw the perpendicular bisector. The easiest way I know how to do that is to use a sticky note. Okay, so I'll take my sticky note, line it up here, okay, and then fold it halfway. And since the sticky note gives me a perfect right angle, and I folded it halfway, I've just drawn my perpendicular bisector right there. Boom. But remember, it needs more than just one perpendicular bisector, so I'll pick two other points. Let's use D and D prime. Okay, and you can do this with any number of points, and draw the perpendicular bisector from there. Okay, fold that in half. Perfect. Okay, and there is, oops, my perpendicular bisector between those 2 points. And so I could do more of these if I wished, but by the properties of reflections, the center of rotation is right here, and we will call it point P. You can go ahead from here and find out the angle and the direction, everything like that. But for now, we'll stop here. That is how you find the center of rotation using the honors method.